Today, let's find what happens when helium is added to a system at chemical equilibrium, using the ammonia formation reaction as an example. Consider the equilibrium reaction. This is a reversible reaction, meaning it can proceed in both the forward direction, forming ammonia, and the reverse direction, breaking ammonia back into nitrogen and hydrogen. At equilibrium, both processes are still happening, but at the same rate. Because of this balance, the concentrations or partial pressures of all gases remain constant over time. Now, imagine we add helium gas into the container. Helium is an inert gas, meaning it does not react with any of the substances in the system. It simply mixes with the other gases. If the container is rigid and the volume stays constant, adding helium increases the total pressure, but it does not change the number of moles of nitrogen, hydrogen, or ammonia. Therefore, their partial pressures remain unchanged. Since equilibrium depends on these partial pressures and they have not changed, the system does not shift in either direction. The forward and reverse reaction rates remain equal, so the equilibrium position stays the same. Therefore, the amount of ammonia formed remains unchanged when helium is added. In contrast, if we had changed the volume of the container or directly changed the concentration of one of the reacting gases, the system would respond by shifting the equilibrium position according to Le Chatelier's principle. In summary, adding an inert gas like helium at constant volume does not affect equilibrium composition because it does not change the partial pressures of the reacting species. Do you want to know the difference between a direct, irreversible reaction and an equilibrium, reversible reaction, and how to identify them? We'll be discussing that this week's newsletter. Check our landing page for more information. Yours Atom Academy.